simplify this indefinite integral here. So we've got 3x times sine 5x. Okay. Now there is potential here for a substitution. You could let u be 5x and things like that, but that's never, and you're welcome to on your own try that out. It's not actually going to get you a much simpler integral. Okay? If, and this is just off the top of my head, if you let u be 5x, you will manage to change this to be, I think, 3u sine u. Okay? It's not really, or it might be over 5 or 25 or something like that, but it's not really going to help you out a whole lot, because whatever it is, you're going to get a u times a sine u and then some constant work. Again, try it out for yourself. I'm not going to do it here. Okay? But you try it out for yourself. You're more than welcome to try a substitution, but it's not going to result in something that's substantially simpler. That you say, oh, aha. Now, if somehow it got rid of the extra x and it was integral of sine u, then yeah, that would be a great substitution. Okay? So even though then you could experiment with a substitution, let's skip over that and get to the real core of the problem. We're going to have to use integration by parts. Right? We got one function times another, which is a great way to recognize that potentially integration by parts might come into play. Right? It's the reverse of the product rule. Not product rule and quotient rule, I guess. So it's definitely something to try out. So if we're going to do an integration by parts, we need to pick our u and our dv in order to use that formula. Right? u dv equals uv minus the integral of v du. So what should be our u? What should be our dv? Okay? For this one here, I see that I've got a trigonometric function. Okay? Other than when you have an exponential function, usually it's a good idea for your trigonometric function to be your dv. So that's exactly what we're going to do. We're going to let dv be sine 5x. Okay? And then working backwards, and here's where you could integrate this with a substitution. You can get minus cosine 5x over 5 for your v. All right, well, if that's my dv, whatever's left over should be my u. So we get 3x here. And then differentiating, we get du would be 3 dx. Okay. So now we make the switch. Okay, so it's u, v, so 3x, cosine 5x over 5, put a little minus there, minus the integral of v du. All right, let's bring the constants out. So the minus, the 5, the 3. Turn this into minus 3x cos 5x over 5 plus 3/5. And then look at that. We've got an integral of cosine 5x. And we can do that. You can do it with a substitution if you want. Or you might just have enough experience to say, I know what to do when it's just ax on the inside. But we can work that out. That's a much simpler integral. So we get 3 over 5. It'll go to sine 5x over 5. So let's merge those 5s on the bottom. So we'll say plus 3 sine 5x over 25 plus c. And we're all done that one.